Hello and welcome everybody to the physics pages. Today we are going to solve Cambridge IGCSE Physics Paper 4 Theory Extended. This paper is from February March 2025, paper 42. Question number 1. Figure 1.1 shows a force versus extension graph for a spring. We know that whenever we have a spring, a mass is attached with the spring, what happens is as the load increases, means the force increases, extension increases. Force is proportional to extension. This is told by the Hooke's. And if we write this equation, we can say F is equal to K times extension. Here we need to remember one more thing, that K is proportionality constant, and this is called spring constant, and spring constant K is equal to load, or we can say force in newtons, divided by extension in the meter. So we can say that K is F over E in Newton per meter. Here in this graph, we can see there is a force given and also extension given. Force is on vertical axis, y-axis, 1000 Newton, 2000, 3000, and on x-axis you can say there is 0.02, 0.04 meter extension. So this is our graph, that is a straight line. First part says calculate the spring constant K of the spring. First thing first, as I told you from the Hooke's law, spring constant K is always equal to load over extension, F over E. So F over E in this graph, force is on y-axis and E on x-axis. That can also be said that it is the calculated from the graph by finding the gradient of the graph. Whenever we are going to find gradient of given graph, so we will easily find. So to find gradient, we have two ways. One is either just simply we can find a rise over run, and other is you can use y2. You will choose 2 points, you know that y2 minus y1 over x2 minus x1. So here we can use this one, or you can say k is equal to rise, that is y-axis, over run. So I am going to start with the easier thing, that is rise over run. For that I would need to choose 2 points. The points that I am going to choose are the simple points. I have this point, I'm starting from 0 0, and I am going at this point, that is 0.08 and 4000. So if I draw the line, this line shows the run, and here this line, if I move downward, this line shows me the rise. So I can just simply say that this is rise, and rise is around 4000 newtons, and run is also 0.08 meter. So when I substitute these values, what I get for the K is 4000 divided by 0.08. Here I need to mention that 4000 is Newton and 0.08 is meter. So when I divide 4000 by 0.08, I get 50,000. So this can be 50,000 And as we said, that force is in Newton and extension is in meters, so 50,000 Newton per meter. So I can simply say 50,000 Newton per meter, or there is another way. If I write in standard form, that can be written as 5.0 into 10 to the power 4 Newton per meter. So both of these answers are considered correct because I try to write in two significant figures. Part B of the same question is, a student states that the spring has not reached the limit of proportionality. We need to understand one thing, that limit of proportionality is the limit in which spring is at its peak, that after that it will completely deform, it will not return back to its original state. So if we have a graph, after limit of proportionality, graph does not remain a straight line. For example, this is our load and extension graph. So this one, if it is straight, this says that it is a proportional. But after this, when it tend to change, that extension doesn't remain proportional to the force. This is beyond the proportional region. So this is called limit. So limit of proportionality is this. Now, student says that spring has not reached the limit of proportionality when force of 4,500 Newton is applied to it. State how the graph shows that the statement is true. We have to tell that how graph shows. So if you go back to the graph, we can see that graph is just a straight line until 5,000 newtons. So there is no curve, no bend. So it means that force and extension are proportional. So here we just need to mention that the graph is the graph is a straight line, which means that straight line which shows that force is proportional to extension. Also, gradient of graph, gradient of graph, that was force over extension, is constant. So this is the proof that this is this graph doesn't reach to the limit of proportionality. Let's move to part C. Spring can be compressed by forces. When you apply force, either spring is compressed or extended. So the spring described in figure is compressed by a force F that has extension negative 0.025. Whenever there is a compression is represented by the negative. So we know that we are asked to find force. So there is rule, as I mentioned earlier, that is Hooke's law, that says the relationship between force and extension or compression is K times A. We just mentioned that previous part, that K is 50,000 Newton per meter times E, extension is negative 0.025. When we multiply, our answer is 1250. Here I would like to mention that K is Newton per meter and extension is meter. So meter and Newton per meter is cancelled. So we can say extension is negative 1250. It will be rounded to 1300. We can either say that this is negative 1300 Newton, or we can just simply say that this is the force that is in opposite direction. So opposite to the other applied force. If it was to the right first, now it will be to the left. Last part of the same question is state whether force is a scalar or a vector quantity. When we say scalar quantity just need the size, only the magnitude. So scalar need only magnitude. Whereas when we say the vector quantity is that has the size, you can say the magnitude and direction in it. So force is a quantity that has a magnitude and direction. So we can simply say force is a vector quantity as it has magnitude along with along a specific direction. Specific direction. Like you can say weight is a force that is always toward the center of the earth. Thrust is a force that is against the air resistance. So many friction is a force against the motion of the object. So all of the forces has the direction. Question number two. As we can see in the figure, there are two trolleys. The statement says that trolley A and trolley B are on a horizontal frictionless bench. Trolley A moves to the right. So this trolley you can say is moving to the right. Trolley A is moving to the right with a constant velocity mentioned as 0.44. So I can just simply say u is equal to 0.44 meter per second. Trolley B is stationary, so I can just simply say u is equal to 0.0 meter per second. So this is stationary. This figure 2.1 shows trolley A before it collides with trolley B. State the momentum of trolley B before the collision. The statement for this is momentum is zero. Why momentum is zero? Momentum is zero because we know that momentum is always equal to momentum is always equal to mass times velocity. And here trolley B is at rest, which means that velocity is 0 meter per second. So when you multiply with the mass, whatever the mass is, so you can say, so momentum is 0. Momentum is 0 as well. Next part says that after the collision, the two trolleys are joined together. When these trolleys are joined together, you can say if this is the first trolley, it is coming towards the second, and the second trolley and first trolley are joined together. They are pushing each other and moving together. And both of them now move to the right. I mentioned it. This is to the right, that is 0.18 meter per second to the right. That's the same direction that trolley A was. Okay. Now, the mass of the trolley A is 0.75. We can just simply say that this is the situation after collision. And if you want to revise before collision, it was like this is trolley A that they are saying having the mass of 0.75 kilogram. This is the mass of trolley A, and this trolley A, as mentioned in the first figure, was moving with 0.44 to the right. So this is 0.44 meter per second. But the second trolley B, we don't know the mass of this trolley. We are unaware about the mass. It was not moving, it was at rest. Now, the question says that the mass of the trolley bay is unknown, that we are asked to find. According to conservation of momentum, we know that momentum of a system, momentum is denoted by P. Momentum of a system before collision is always equal to momentum of a system after collision. So, if we talk about momentum before collision, this is the before collision. Mass of the trolley A times velocity of the trolley A, 0.75 times 0.44. This is momentum of the trolley A, plus momentum of the trolley B, as we found in part A, is 0 because it's not moving. Even we don't know the mass, but we don't have the momentum because it's not moving. When we move to the after collision, here both trolleys are joined together, so it is a one system. So we can just simply say that mass of the trolley A, that is 0.75, plus mass m of the trolley B times their common velocity is 0.18 meter per second. So left hand side When I simplified, it gave me 0.75 times 0.44. It is 0.33 plus 0. So I will just simply say 0.33 is equal to 0.75 plus the unknown mass of trolley B times 0.18. As 0.18 is multiplied, I divide it on both sides, so it will become 0.33 over 0.18. It gives me it gives me 1.833. It is 1.83 bar, and here it is 0.75 plus m. Now I need m, so what should I do? I will move this 0.75 on the other side, and it will be subtracted from 1.83. So what can I say? 1.83 minus 0.75, it gives me 1.083. So mass is 1.083 bar is m, and mass is calculated in kilogram. Rounding it to two significant figures, 1.08 is rounded to 1.1. So because 8 is more than 5, so if I round it, it will add 1 to the previous number. So this is 1.1 kilogram. So this is our required answer. The next part says the trolleys move onto a rough surface, and which exerts a constant force on trolleys and bring them to rest in 2.6 seconds. If we say that these are the two trolleys which are already joined, we are moving to the next part when these are joined. These were moving on a straight part, and their speed we said is 0.18 meter per second. Here I will say that this is initial speed. After that, these trolleys go to the rough part, and roughness of the surface make their motion to slow down until these two trolleys become at rest. So their final velocities, I can say v is 0. Here I can say that this is, I would better mention it as u. Initial velocity is 0.18 meter per second, and it's to the right, both of these. And both of these trolleys, you know that this trolley A has mass 0.75, mass of A is 0.75 kilogram, and mass of B, you know that 1.1 kilogram. Now you are asked to find the force. There is a relationship between force and change in momentum according to Newton's second law in terms of momentum. Newton's second law. Newton's second law says that the force is always equal to rate of change in momentum, delta p over delta t. We can just simply say that it could be m delta V over delta T. And by the way, that is also the same Newton's second law, ma delta V over delta T change in momentum. So now, force is equal to mass of the both objects is 0.75 plus 1.1 into V minus U over time it takes is 2.6 second. So if I so the resistive force uh, we have to multiply it with the change in velocity. So change in velocity is 0.18 meter per second to 0. So that is 0.18 meter per second. Now this changes to 1.85 time 0.18 divided by 2.6. If I use the calculator, I can just simply say that it is 1.85 times 0.18 divided by 2.6. I got is 0.129. So force is 0.129 into significant figure. I can say resistive force is 0.13. I can just simply say 0.13 Newton. It is opposite direction of the motion because this is resistive force. A different rough surface exerts a smaller resistive force, smaller than the obtained one. State how this affect the time taken. Smaller resistive force effect on the time taken to bring the trolleys to the rest. The statement is, we can say, it will longer, take longer to stop. It will take longer to stop, or it will increase the time. You can just say increase the time. Why? Because we know that resistive force F is equal to delta P over delta T. We can simply say that force is inversely proportional to the time it takes. So it means that less force means less the force, more is the time, more is time to stop the trolleys. Trolleys. Question number 3. Figure 3.1 shows a main electric heater used to heat a small room. In the figure, we can see there are two heating elements and there is a shiny surface behind them. State the region of the electromagnetic spectrum in which radiates thermal energy from the heater. We are very well aware that this is for thermal radiation, it is infrared region. Infrared region. Explain why the shiny surface behind the heating element increases the thermal energy radiated into the room. We know that any shiny surface is shiny surface surfaces are very good reflector, very good reflectors of heat, reflectors of thermal radiation, thermal radiation. As shiny surface reflects almost all of radiations, room temperature increases. The metal outer casing of the heater is earthed. When we use the word earth, it means it's a wire that bypass the current from the surface to the earth. Why it is important for the safety feature? If body of heater, or you can say the casing of heater, is short circuited, short by touching the wire, by touching a wire, earth wire will direct excess current to the ground, current to earth. So it will not harm. We can also say that when earth wire is attached, so with the short circuit, there will not be any harm for the person who is touching that wire. The mains voltage is 230 volt. The two identical heating elements are connected in parallel. Each heating element has a resistance of 89 ohm. When heating elements are in parallel, it means they will have the same voltage. In parallel combination, we know that voltage is always same. So when voltage is same and also these are identical, resistance is same, so you are going to calculate the current. For the current, we have a relationship that voltage V is equal to current time the resistance, or you can say current is equal to voltage divided by the resistance. Here we have voltage of 230 volt because these two heating elements are in parallel, same voltage and identical, same resistance 89 ohm. So we can just simply divide them and get the answer 2.58. That is 2.58. This one we have to remember that 2.58 current is always calculated in amperes, so I will round it to 2.6 amperes. Show that the electric power of the heater is approximately 1200 watt. So we have to prove it. State an equation you use in words or symbol. So we are going to find power. To find the power P is equal to current times voltage. This is one equation. Power P is also energy delivered per unit time, but that is not important here. I am using here current into voltage. I can write in word as well. Power is equal to current times voltage of the main supply. Here I would like to mention one more thing. If I draw it, it's better to do it. For example, this is the main supply 230 volt, and here are two elements which are in parallel. Thermal elements are in parallel. So what is happening here? We need to remember that this 230 volt is applied across each 89 ohm resistance, and current through one of this is 2.6, and the other one is also 2.6. So the total current provided by the battery is 2.6 plus 2.6. So I will say that this current I is 5.2 ampere. Now getting back to the equation, as I said, power is equal to current time voltage. So current is 5.2 amperes and voltage is 230 volt. So the power will be 230 times 5.2. It is 1196. 1196 watt, and we approximate this as power is equal to 1200 watt. So that is our result. The next part says that the heater is 95% efficient. So efficiency is 95% at converting electrical work done to the thermal energy. Calculate thermal energy emitted by the heater in part 2 in 60 seconds. Give your answer into two significant figures. First of all, we know that efficiency is equal to output work over input times 100. So efficiency is 95%, and we are asked to find thermal energy. And you know that energy is equal to power into time. Here we are having two equations. First one is efficiency, and second one is power. So output power, I would like to calculate if efficiency is 95%. So I can just simply say 95% is equal to output over input. The input power we have uh, 12,000, sorry, 1,200 if I am not wrong. Yeah, the power input is 1,200. So you can say 95% of 1,200 is equal to output work. Output power or work, you can say that. So 95% mean I will multiply 95 by 1,200 and divide it by 100. It's 1,140. What I have done, 95 times 1,200 divided by 100, it gives me 1,140 watt. This is my output power. So energy, that is thermal energy emitted by the heater, is power 1,140 times 60. So I multiply it by 60, 68,400. So energy 68,400 joule. So I can round it to 68,400 divided by 1000. So 68.4 kilojoule, that is rounded to 68 kilojoule. So 68 kilojoule is the answer. Question number 4. A train has a maximum speed of 200 kilometer per hour. This is 200 kilometer per hour. It accelerates from rest. This is very important to mention, from rest to a constant acceleration of 0.70 meter per second. First thing first, define acceleration. We are very well aware acceleration is change in velocity or change in velocity over time, but the specific definition you use, we can say it is rate of change in velocity. Rate of change in velocity. Here I would like to mention one thing. We cannot use the word speed here, but we can say change in velocity over time or change in velocity per second. So we can mention here in another way, we can say change in velocity per second. Velocity per second. Not speed. Many times students use the word speed that is not appropriate for the velocity, for the acceleration, sorry. Show that the maximum speed of the train is approximately 56 meter per second. So this is, we are asked to, here we are given by maximum speed, and maximum speed in the question was given in kilometer per hour, that was 200 kilometer per hour, and we are supposed to convert it into meter per second. So maximum speed, that is, I can denote it by V, that is 200 kilometer per hour, and I need to convert it into meter per second. Before I go further, I would like to mention that 1 kilometer is always equal to 1000 meters, and 1 hour is always 60 minutes, and each minute is always 60 seconds. So when I am moving to convert 200 kilometers per hour, I need to convert kilometers into meters. So I will just say 200 kilometer mean 200 times 1000 meter, and 1 hour will be 60 minutes, and each minute into 60 seconds. So this will become 200,000 meters, 200,000 meters over 3,600 seconds. That will go to 55.55 meter per second. I can round it to 56 meter per second. Calculate the time taken for the train to reach its maximum speed. So, train has to reach at maximum speed, but we know the relationship for the acceleration, that acceleration is always equal to rate of change in velocity, delta v by delta t. So here we need to calculate the time. I can just simply say the time taken will be equal to change in velocity over acceleration. And change in velocity can also be further found by final velocity, which is maximum velocity, minus initial velocity, that it starts from the rest, over the acceleration. For substitution of the values, the time train takes to reach the maximum speed will be final velocity 56 meter per second minus 0 meter per second over the acceleration was mentioned in 0.70. I will write here 0.70 meter per square second. So I can just simply say 56 divided by 0.70. So this one will be 56 minus 0 is 56 divided by 0.70, and it comes to 80. Delta T is equal to 80. Here we have to be sure what unit is. In the top it was meter per second, and in the denominator it was meter per second square. So that gives me that meter per second over meter per second over meter per second. So meter per second is cancelled. 1 over 1 over second, that gives me second. So the time for me to reach the train at maximum speed is 80 seconds. The train has a total mass of 440,000 kilogram. Calculate the force that causes the acceleration of the train. According to Newton's second law, force is always equal to mass times the acceleration. The mass is given to us, that is 440,000, and acceleration is 0.70 meter per square second. So 440,000 times 0.70 gives me 308,000. So this is 308,000 Newton. That can be either rounded to 310,000 Newton. And if I want to convert into kilonewton, so I will divide by 1000. So it will be 310 kilonewton, because whenever we are going to convert from normal unit to kilo, like newton to kilonewton, gram to kilogram, we divide by 1000. So the final answer for the force is 310 kilo Newton. The second part says that the train travels into headwind. The force of this headwind opposes the motion of the train. State and explain the effect of this force. When headwind force is opposite to the motion, so you can just simply say that the train will slow down. Train slows down, or motion of the train slows down, or you can say velocity reduces. Velocity reduces. How this happens? We know that because of the opposite headwind force, net force will reduce. Net force reduces due to the headwind that causes acceleration to acceleration to decrease. Less acceleration due to less force will produce less velocity. So causes acceleration to decrease and velocity also decreases. Decreases. Question number 5. A light dependent resistor LDR. LDR is a resistor that depend on the light. As the light intensity get higher, the resistance get lower. So you can just simply say resistance will be lower when light intensity will get higher. On the other hand, the resistance will get higher when it is dark. So light intensity is low, resistance will get more. So here one more thing we need to remember, light dependent resistor is like normal resistor, but we have to show that the light is falling on it. Here we are asked to sketch the graph between resistance on y-axis. Let me draw. This is the resistance, and resistance is usually measured in ohms, and symbolical representation is omega. It is increasing upward. On the other hand, we have x-axis that is showing light intensity, and light intensity is measured in watt per square meter, and it is increasing to the right side. It is increasing in this side. Now, as we know that as light intensity increases, resistance decreases. So let me say that this is the point where it is dark. So in the dark, resistance will be maximum, and as light will increase up to some point, the resistance will keep on decreasing with the light, and then it will not touch the x-axis because it will contain some resistance value. So we can just simply say that as light intensity increases, resistance decreases gradually. So this curve is showing decrease in the resistance with increase in the light intensity. Part B in figure 5.1, part of the electric circuit used to turn on light when it is dark. So it means we need to introduce here light dependent resistor. So the place of light dependent resistor is given. We have to make it parallel to the fixed resistor. This is light dependent resistor, but we have to put the arrows that light is coming toward it. So this is the light dependent resistor. Explain why the lamp is off in the light and the lamp is on in the dark. We have to use the idea about the potential difference in the answer. Let me get back to the point. It's mentioned in the first part of the question that this LDR, what happens in the dark? In dark, resistance of LDR increases, due to which what happens? R LDR increases. As there is a dark, resistance increases. As resistance increases, potential difference across LDR becomes more, it becomes higher. or potential across LDR is more as compared to the potential difference of fixed capacitor. So what happened is we know that voltage is proportional to R. More the R, more will be the potential difference across it. So it will be brighter. So lamp, due to more potential difference, lamp will be brighter, bright. But in the other case, in light, what happens is in light, resistance across LDR becomes less than resistance of the fixed resistor. So potential difference across LDR is approximately 0. So there is no potential difference. So no or very small, very small or almost no light is obtained from lamp. No light from lamp. So we will not find any light from the lamp. Question number 6. It says that figure 6.1 shows an object O is 5 centimeter away from the center of the thin converging lens L. So this is the converging lens L. This is the object O that we can see here, and it's 5 centimeter from here. This one is from here till here, 5 centimeter. The focal length L is 3 centimeter. Focal length, we know that is a point where all the parallel rays converge and meet. That is focal length, and it's the same on either side. The figure is shown up to the scale. So this is up to the scale. On the figure, label principal axis with P. Principal axis is a line that passes through the center of the lens. So this line is P, principal axis. So I would like to mention here, this is the P. P is principal axis. Part B says we have to place a letter X at a focal point. So for focal point, we have been given 3 centimeter distance. So I will mark 3 centimeter point on either side. This is the point 3 centimeter on the left side, that is showing focal point. Same way, I am going to mark another 3 centimeter mark on the other side. So both of these points are representing the focal point. Let's say this is X, and this is also X. So we have both X and X on both sides. Okay, this is showing focal point, and I want to mark it from here till here. From this point till this point is 3 centimeter. This is 3 centimeter, and the same way on the other side is from here till here is 3 centimeter. It is also 3 centimeter mark. So this is focal point, part B. Moving to third part of the question. On figure, draw two rays from O to locate the tip of the image produced by the lens. Okay, this is very important to understand. Whenever we try to form image, there are three rays. Those rays, after passing through the lens, meet at a point to form the image, and they want us to draw any two. So I will show you the first ray. For example, first ray is always parallel to principal axis. This is a ray which is parallel to principal axis, and after passing through the lens it should pass through the focal point. Okay, this is the ray 1. This is ray 1, which is parallel to principal axis, passes through focal point. So I'm just mentioning here ray 1 parallel to P, passes through X. Okay. Second ray is the ray that will pass through optical center, going through here, and it goes straight. So I will join these 2 points. So this is the image of the object. Now this is the tip of the image. We can see this is the tip of the image, so I can just say this is image. This is our image of the object of ray diagram. Here I would like to mention that this image is real because it is on the other side of the lens. It is inverted, and also it is enlarged. We can see that it is larger than the actual object. So this is enlarged, real, and inverted. Moving to fourth part of the same question. In this table 6.1, place a tick in the right hand column next to all the terms that describe the image in the previous part. So if we look at here, we said the image was enlarged, it was inverted, it was real. So these all are the ticks for the same question. Sorry, the object move closer to L. Okay, the new distance between L and the object is less than the focal length. For example, I draw the object here. Let me choose a different color here just to show the new position of the object. Let's say this is the new position. This is F. So new position is this one. This is the new position of the object. Now describe how the new image. If I draw the same two rays, the first ray is this, the second ray that passes through the optical center is this. This is ray 2, this is ray 1. Now if I extend these rays in backward direction like this one, this is going, it seems to come from the optical center, and the other ray that is emerging from the uh, focal point. Both of these rays, when I extend in backward direction, these seems to meet at point here. And if I see this point is the image point where we can form the image now. So this image is obviously virtual. Why it is virtual? Because this image is formed on the same side of the lens. So the new image will be, new image is virtual. New image is virtual, number one. Number two is upright and enlarged. Enlarged. And this property of the convex lens, when object is in between focal point and optical center, we call it magnifying glass. So this behaves as magnifying magnifying glass. So this convex lens is now behaves as magnifying glass. Question number 7, part A. Figure 7.1 is a scale drawing, that is up to the scale, of a light wave approaching to the narrow slit. The scale shown here is 1 centimeter represents 4 into 10 to the power negative 7 meters. You can see these are the crests of the light wave front, crest of the light wave front, and this is a slit, and after slit light passes. When light passes through the slit, we know that it will bend around the corner, and this process is called diffraction. So here in first part, name the wave effect produced by the narrow slits. So you can say here this is named as diffraction of light. Second part says that using figure 7.1 determine the wavelength of the light. First of all, wavelength is denoted by the lambda that we are supposed to find. Give your answer into two significant figure. We always give our answers into two significant figure. Now we are going to find wavelengths. For that one, I need the distance between two consecutive crusts. So we have to find wavelength lambda is distance from one crust to another. So we are supposed to find wavelength. The definition of this I just wrote it here. So for that purpose, I am going to use the scale, and if you look at the scale, the distance from one crest to another crest, this one is 1.2 centimeter. And similarly, if I see from here to here, this is 2.4. So 2.4 divided by 2 will also give me the same, or I can just simply see the other for the confirmation. Here I can just simply say that this distance from first wavefront crust to another is also 1.2 centimeter. Okay, now we are sure that the distance between crust to crust in centimeter is 1.2, whereas scale is 1 centimeter as this. So here I am going to talk about that wavelength is equal to 1.2 centimeter, but we know that scale says 1 centimeter is equal to 4 times 10 to the power negative 7 meter. So I can say that wavelength is equal to 1.2 times 4 into 10 to the power negative 7. That provides me 4.8 times 10 to the power negative 7 meter. Now here we can simply write this answer as 4.8 into 10 to the power negative 7 meter. That is correct, but it is closer to nanometer. Wavelengths usually we take in nanometers. This one we have to remember. uh, Wavelength lambda is always measured in nanometers, and here I need to mention 1 nanometer is 10 to the power negative 9 meter. So to convert this in nanometer, I multiply full with 10 to the power 9. So this gives me 4.8. Will change it to 480 minus 7 plus 2. So this is 480 nanometers. So this one, as you can see here, this will change it to 4.8 into 10 to the power minus 7 plus 9 is 2, so 100, so 480. On the figure 7.1, draw three wavefronts that have passed through the narrow slit. When these rays pass through the narrow slit, so diffraction process says that these rays will bend. So bending of rays will cause like this. This is one wavefront and almost same wavelength on the other side. This is second, and this could be the third. Here I
want to mention that this length is 1.2 centimeter. I know this might not be up to the scale, but if I am writing is 1.2, so this is 1.2 centimeters. So this wavelength after diffraction, wavelength remains same. So this one remains same after diffraction. So we need to keep it in our mind that when diffraction phenomena occurs, the wavelength remains same. So wavelength is same before and after the diffraction. Moving to second part of question number 7. A foghorn emits a sound with a frequency of 380 Hz. We usually use frequency with F, and also we have to remember Hertz is per second. It is representing 1 over second. So Hertz mean 1 over second. Okay, so frequency is 380 hertz can also be considered as 380 per second. The sound is heard by the ship 2.5 kilometer away. So this is the distance. Let me mention distance by d from the foghorn. The speed of the sound in air is 330 meter per second. We usually represent speed by v. First part says show that, means we have to prove this. Wavelength of the sound is approximately zero point 0.9 meter. We also have to state the equation to use in word or symbol. I will write in both. We know that speed of a wave is equal to frequency times wavelength. In symbolical representation, I will say V is equal to F times lambda. So if I draw a triangle, I can simply say that V is equal to F times lambda. Now here, our question is to find the wavelength. Our question is to find the wavelength. So I rearrange it and I will say wavelength is equal to speed over frequency. Now trying to solve it, wavelength is equal to speed is 330 meter per second over frequency is 380 hertz. I can also say hertz or per second. Now first thing first, I will divide 330 by 380. What I got is 0.868. So this is 0.868. Now it comes to unit. If I focus on the units only, the numerator is meter per second, denominator is 1 over second. So if I solve it, keep, change, flip, I keep meter per second, I change division into multiplication and flip 1 over s to s over 1. So s cancelled, so only unit left is meter. So I can say wavelength in two significant figure, or simply it was 0.868, so I can say 0.87, that is approximated to zero point 0.9 meter. That was our concerned result. Part B, second part says calculate the time it takes. So now question says you have to find the time for the sound to travel to the ship from the foghorn. If I redraw another triangle to show the relation between speed, distance, and time, we know that speed, that was represented by v, is always distance over time. So here I can just say time is equal to distance divided by speed. So distance here is, I think it was given 200, 2.5 kilometers. Distance is 2.5 kilometers and speed is 330 meter per second. Here is very important point that we need to understand. The numerator is giving kilometers, whereas denominator is giving meters per second. So units are not synchronized. So we need to make them similar. For that purpose, the first thing I have to do, I have to convert kilometer into meter or meter per second into kilometer per hour. So kilometer to meter, we know that 1000 meters are equal to kilometers. So 1000 meter is 1 kilometer. So I have to multiply it by 1000. So the time taken will be equal to 2.5 times 1000 meters, now unit is, over 330 meters per second. Now it becomes 2500 divided by 330. It gives
Time is equal to 7.575757. So I can say 57 bar. Now to confirm the units, we know that meter is numerator divided by denominator is meter per second. I keep the meter, change the division into multiplication and flip meter per second to second over meter. Meter is cancelled and unit is second. On simplifying it, it gives me 7.57 is 7.6. Question number 8. Figure 8.1 shows a metal rod suspended in magnetic field produced by pair of permanent magnets, as this is north and south permanent magnet. The metal rod is connected to the cell and there is a current in the metal rod. So first of all, we need to mention from the cell, as we know that this is the positive terminal and this is the negative terminal. Current starts from positive toward negative side like this and it completes the circuit. So this blue line I am just trying to draw just to show that this is the direction of current. And magnetic field, I try to draw from the north to south. These are the magnetic field lines. These are magnetic field lines. Now, magnetic field lines are perpendicular to the direction of the current.
First part says that state the direction of the force on the metal rod due to the current. So I would like to mention here, for finding the direction of force, we have to use Fleming's left hand rule. What was the Fleming's left hand rule? Fleming's left hand rule says that if we extend the three fingers of our left hand, including thumb, our first finger, and middle finger, like stretch perpendicular to each other. So, first thumb represents the force, first finger represents the magnetic field, and middle finger represents the current. So, if I turn my first finger toward magnetic field and second finger toward the current, so current is away from me, magnetic field is from my left to right, so force is downwards, that is in this direction. So I would like to mention here the downward direction for the force. Let's say this is the direction of the force from Fleming's left hand rule. So first question or first part says that what is the direction of the force? Direction of the force is downwards toward bottom of the page. So this is downward. Second, how we will explain from uh, Fleming's left hand rule. Left hand rule. From Fleming's left hand rule, when current and magnetic field lines are perpendicular to each other, perpendicular to each other, each other, magnetic force will also be perpendicular. Force will be perpendicular to both of them. Perpendicular to both. Perpendicular to both of them. Now B part says the connections to the cell are reversed. What will happen? Now when connections are reversed, the direction of the current that was initially away from me into the screen or into the paper, you can say, now this current will automatically change. This will become positive, this will become negative, so current will be from here to here. So according to Fleming's left hand rule, magnetic field is toward my left to right. The current is now toward me. The force will become upward. So it means the current direction reverses the direction of the force. So you can say force will reverse. Force direction will reverse. So it will be upward now. It will be upward. So direction of the current changes the direction of the force.
Question number 8c. Two magnets and a cell are used to make a simple electric motor as shown in figure. We know that electric motor is a device that converts electric current into mechanical work or rotation. So this is current to work, mechanical work or rotation. And its schematic diagram is shown here. These are two permanent magnets that provide magnetic field, and there is a cell joined with the external wires passing through the current passes through the carbon brushes to commutator, split ring commutator, to rectangular coil and axle, and all of these are the things. So here, question is asked that describe the function of J, K, L, and M. So first of all, J is uh, we can say that these are carbon brushes. What are the carbon brushes? So actually, J represents carbon brushes. These carbon brushes are actually provide the connection between wire, provides connection of cell through wires to split ring commutator. So these split ring commutator provide this uh, current provided by the battery to the rectangular coil. Now coming back to K. K is a rectangular coil that rotates. K is rectangular coil rotates inside magnetic field, inside magnetic field due to presence of electric current. Electric current. So electric current that is inside these rectangular coil and magnetic field external, they interact and the coil rotates. L in the figure is axle. Axle, it allows motor or the coil to rotate or you can say spin smoothly. Okay, M is split ring commutator, split ring commutator. Its function is to reverse the
direction of coil in every half cycle to make smooth rotation in one dimension. To make a smooth rotation. Question number 9. Strontium 90 is a radioactive isotope of strontium. The nuclide notation for the strontium 90 is here. We know that whenever a nucleus is denoted as a symbol, there are two things that we usually represent. At the bottom, we use atomic number, and at the top, we use mass number. Atomic number is either number of electron or number of proton, whereas mass number is number of proton plus number of neutron. Okay, here we have 38, either number of proton or electron, and we have 90 mass number, that is proton plus neutron. Part A. Explain why what isotopes are. First thing first, isotopes are the elements with same number of protons or electrons, but different number of neutrons. Here I would like to mention one more thing. The number of protons are always equal to number of electrons. So we don't need to mention both of them. We can just simply say number of proton or number of electron. Secondly, number of proton or number of electron is also called atomic number. So we can also say that having same atomic number. So this can be said isotopes with isotopes have same atomic number, same atomic number, but different mass number. So mass number is A, that contains protons number of protons plus number of neutrons. So this can be atomic number. So atomic number is different but mass number is same, are also called isotopes. Here comes the table in part 2. Complete table 9.1 for strontium 90. We know that whenever we have an atom has two basic parts, nucleus and surrounding space. Usually electrons revolve around the nucleus, whereas protons and neutrons reside inside the nucleus. So here is outside the nucleus. So when something is outside the nucleus, it means it's the electron. Electrons are outside the nucleus. And I told you that number of electron and proton are same. So number is same. So this one is proton inside the nucleus with a positive charge. The remaining is neutron. So neutron is also inside nucleus. So you can also say nucleides because proton and neutron remain inside. So how much is the number of neutrons? So number of neutron we can simply say number of neutron can be calculated by atomic number minus mass number. So neutrons are equal to atomic number 90 minus mass number 38. So 90 minus 38 will be 52. So this is 52. Part B. Strontium 90 is used to measure the thickness of the metal sheet in industry. So whenever we are trying to measure the thickness of the metal sheet, we use strontium 90. Strontium 90 decays by emitting beta particles which pass through the metal sheet to the detector. And beta particle has high penetrating power, that is up to uh, approximately 10 millimeter, or in some in air it may be in centimeters, but I'm talking about metal sheets. It can pass through about 10 millimeter. One metal sheet is 0.75 millimeter thick. Suggest why strontium 90 is suitable radioactive source to measure the thickness of the metal sheet. So strontium 90 is used because it is used as almost all beta particles pass through 0.75 millimeter thick metal sheet, but count rate differs as thickness changes. So as thickness changes, the amount of count rate will change. So more count rate shows thinner metal, and less count rate shows the thicker metal plate. Part 2. The half-life of the strontium 90 is approximately 27 years. We know that half-life is a time in which half of the radioactive sample decays and half remains. So this said that percentage of strontium 90 after almost 27 years becomes 50%. 12.5 year it's around this much, 75%. Now the strontium 90 source is replaced by a new source after 15 years. So we replace it by a new source. Using figure 9.1 suggests why strontium 90 source that is more than 15-year-old need to be replaced. Uh, we can see from here within 15 years almost 70% or less than 70%, so less than 70% of strontium 90 remains after 15 years. So almost after 15 years, less than 70% of strontium 90 remains. So uh, counter needs more radiation, more radiations. Maybe the radiations are less to be counted. Counter need more radiation, excuse me, for counting that can be provided by the new sample. Question number 10. Figure 10.1 shows the path of the Earth as it orbits around the Sun. So we know that Earth orbiting the Sun, and this orbital period is 365 days. That is called 1 year of the Earth. X is a position on the Earth where a scientist observe the apparent motion of the Sun throughout the year. So this X is the position of the scientists. Okay. If we look at this total orbit, we can say the Earth is a tilt of 23.5 degree, and due to this tilt, the different season change, the weather changes. When this Earth is at position H, so you can see this X is on the other side, which is not facing on the other side of the earth, that is not facing the sun. So most of the sun, this side will not face the sun, or it will uh, face the sun for less time. So this will be probability that it is a winter time. On the other hand, when you are at F, so scientists are facing the X because of the tilt. Most of the time they will face the X, so this might be summer and rest two will be winter or spring. Let's move to question A. Determine how many days it takes the Earth to move around the orbit from F to G. First of all, the orbital period of the Earth is 365 days. So number of days it will move from F to G. So period is 365 days, and F to G is uh, one fourth. F to G is one fourth of the period. So we can say simply 365 times one quarter, it becomes 91.25 days. So number of days in two significant figure, I will say 91 days. Explanation: F to G is one fourth, one quarter of total Earth's period around Sun, around Sun. So we divide we divide total period T by 4. So we get this answer. Figure 10.1 shows the position E, F, G, and H of the Earth in the orbit of the Sun. Identify the position of the Earth when it is summer at X. I just told you earlier on that summer is F because the Earth, the part of the Earth facing the Sun is X most of the time. So this is F because it is facing most of the time. Whereas the position of the winter will be H because Earth is very less time facing the Earth. The orbital speed of the Earth around the Sun is approximately 3 into 10 to the power 4 meter per second. Calculate the average radius. First of all, I would like to remind you the speed, that is orbital speed, is equal to 2 pi r over the period t. Here I would like to mention v is the orbital speed, r is the orbital radius. So if we need to find r, we can rearrange r as v times period t over 2 pi. Here I would like to mention v is always in meter per second, time should be in second, and 2 pi is the number, so r will be in meters. Let us substitute the values. R is equal to V, that is 3 into 10 to the power 4 meter per second, times the period. Period of the earth, we just said it's 365 days. Each day is 24 hours, each hour is 60 minutes, each minute 60 seconds. So we need to convert it into second divided by 2 pi. When we divide it, we got 1.5057 times 10 to the power 11 meters. So here I would like to convert it into two significant figure, 1.5 times 10 to the power 11 meter. I can also write it into 10 to the power 12, that will be 15 into 10 to the power 12, that may be terameter, we can also say that. So it can also be 15 terameters, but it's better to keep it in meters. Earth is a planet in the solar system. Yes, we are aware that Earth is a planet like Mars and Jupiter. State one other type of naturally occurring object. Naturally objects are, we can simply say, moon. Moon is naturally occurring object that orbit the planets. Orbit the planets. We can also say asteroids. We can also say um, you can say naturally occurring satellites. Natural satellites are also this. Also comets are also the naturally occurring, but we have to write one of these. So this is our answer. Thank you so much, guys.